Hello everyone, my name is Aditya. So in the last video, we wrote a blink example program and flashed it onto our Arduino UNO board, and we successfully were able to blink an LED, the onboard LED, which was connected to pin number 30. So in this video, we'll try to connect another LED, external LED, to pin number 12, and then we'll try to write the same program to blink the LED. So for that we need to modify our program a little bit. So firstly we need to make pin number 12 as an output pin, and then we need to make pin number 12 as high, then pin number 12 as low. So this program is perfectly fine, and then we'll try to compile this, and yeah, so it compiled without any errors. So but it's a good practice to define the pin. I'll tell the reason in a few minutes. So for that we just need to do as define, and we'll name it, for example, LED underscore pin, and then define this as 12. So now we can replace this 12 with LED underscore pin, and same goes here, LED underscore pin and LED underscore pin here as well. So the reason why I did this is because for example, okay, first let's see why we replace this. So what this does is whenever the compiler sees the LED underscore pin, so it will understand that this is 12 because it was defined as 12. So the reason why I did this is let's say that we change our mind and then we connect the LED to pin number 11. So rather than changing in all places, we can just modify here, and then that works. So this is a very good practice to define our pins beforehand and then write it in the elsewhere in the program. So this is it. Then we'll try to compile this, and as you can see, it compiled successfully. So now let's see the circuit part. The circuit is really simple. We have an Arduino UNO board, and we have pin number 12 in the right hand side in digital input output, and then we have a ground pin in the power pins on the left hand side of the Arduino, and then we need to connect the positive end of LED to pin number 12, and then the negative of LED will go to a resistor of 1 kilo ohms, and the other end of the resistor is connected to the ground. So it's always recommended to use a resistor even if you are blinking an LED to limit the current, because we saw in the first video that each pins of an Arduino, each digital IO pin will have a limit current. So if it exceeds that, so there is a chances of our board or that particular port getting damaged. So it's always recommended to use an resistor if you are using an LED to protect your board. Okay, let's see the circuit. So before that we'll see what are the materials required. So for this I'm using an LED. So in an LED you can see there is two leads. So one is slightly larger or longer than another. So the longer one is positive and the shorter one is negative. Then I am using a resistor, a 1 kilo ohm resistor. Then I am using jumper wires, male to male. Then I am using a breadboard and Arduino UNO. So let us see the construction of a breadboard. So breadboard is a useful tool which is used in electronic projects to make temporary circuits. So in breadboard you can see various columns and rows of points. So on the topmost you can see two rows, the row number 1 and then the row number 2. So there is a division of set of 5 at the middle. So this is the first part and then this is the second part. So the entire first row
is shorted. That means this point over here and this point over here is same. So it is shorted. The entire row is shorted. The first row is shorted till here. And then from here there is a split here, and then from here to the last. So this entire row is shorted. So similarly, row number 2, the entire row is shorted till here. There is a split here, and then from here the entire row is shorted. But these 2 points are not shorted. That means row number 1 and row number 2 are not shorted. So next, here we can see there are 5 rows. 1, 2, 3, 4, 5. So in this we can say each column is shorted. So that means column number 1, entire column is shorted. Column number 2, entire column is shorted, and so on. But the individual row is separate. So that means there is no connection between this and this. There is no connection between this and this. But all these points are shorted, and this individual, the adjacent ones are not shorted. So this is similar to the first 2 rows. Let's see the circuit. So first take the Arduino UNO and then locate pin number 12. So pin number 12 is over here. You can see pin number 12. And then locate the ground pin. So ground pin is over here. So take the jumper wire and connect the red color onto pin number 12. Right there, pin number 12. Then take the orange one. You can also use the black one for the ground if you have. Then connect it to ground. And then the other end of the wire, connect to one of the columns like this, and then connect orange to another column which is little far, like this. So now we need to connect a resistor and an LED across these 2 points. So we know that the entire column is 1 point, that means all are shorted, and this entire column is 1 point, that is all are shorted. So this is from pin number 12. That means the positive end of LED should go to pin number 12. So connect the longer lead right here, and then connect the negative one to 4 places after that, maybe like this. Then take the resistor, connect the resistor to the same point. So we know that all these are same point, all these are shorted, so you can connect the resistor to any one of the point. Let's say I'll connect to this point here, and then connect other end of the resistor to the ground point, which is this. So you can connect it here. So now we have our circuit. So let's recap. So pin number 12 is connected to the positive end of the LED, and then the negative end is connected over here, and at the same point the resistor is connected, 1 kilo ohm resistor, and then the other end of the resistor is connected to this point, that is the ground. So let's power up and let's flash our program.
Okay, so let's flash the program that we have written. So once you connect the Arduino UNO to the computer, you can see the green LED lights up. So click on compile, and we can see there is no error. Then click on upload button. So as we can see, once it's uploaded, we can see the red LED blinking. So that's it for this tutorial of how to blink an external LED connected to pin number 12 of the Arduino UNO. So this is how you write the program and connect a simple circuit. So in this video we have learned how to modify the blink example to connect our own LED to pin number 12 and then flash the program onto our Arduino UNO board. And then we also learned how to make a simple circuit using a breadboard and jumper wires. So hope you like the tutorial. So in the further videos we'll try to do more such mini projects and we'll try to learn more. Thank you.